What's up, dude? Hey. What's going on?
This the one?
We got some good stuff going.
You're the team leader?
You went back to the bar last night, right?
So tell me about your idea
This
then.
morning you should.
Alright, so Adopter brings new companies with new products or new companies together with early adopters to create useful innovation.
Okay. For example, make an example.
For example, Exambi,
Okay.
fellow team,
Okay.
they might need the early adopters such as the families who want a nurse in-house,
Okay.
or the doctors who want to send nurses, and they need feedback from them in order to build their product development.
All right, cool. So you will be the enabler.
Yeah.
All right. Do you have any like oh, so you have something over there, but the company.
Yep, we've interviewed all the other teams, got the features that they like best,
All right. Pretty cool.
and we're about to build.
All right. Excellent. Excellent.
Value proposition.
So you can get volume at the free level.
Hello.
I'm not sure.
Can I cut you off for a little interview?
No. Thank you for asking.
All right.
I'm interested in what you say.
I'm looking to see if it has a scheduling functionality.
Hey.
Hi.
How are you doing?
Good. How are you?
Tell me about your idea here.
Our idea is going through the blender right now.
So you're
So we're making a
you're making
healthy
a protein
of
shake.
ideas.
I thought it was some sort of a mojito or something.
Maybe. But we wait till 12 for that. Oh, it's noon exactly right now.
Okay, so you're hungry then. That's why you're combining food and ideas. That's good. That's good. I get Kevin there. Right. Good. Very good. So,
Everyone's like, oh, there's Kevin.
yeah. Cool. Well, good luck with your idea. What's your name? What's your idea?
Track.
Ah, it was a track it.
Track it.
Track it. All right.
The same software goes faster, costs less money. I'm just trying to distill down what is the one thing that we can actually put a wrapper around and say this is what we're going to make. Because speaking with you, you've got a lot of things, right? Which is a problem. It's undefinable. So it's almost like you need to be acquired by a research department to be stuck in and create all these things. Where I'm trying to go in is pinpoint a product that we're going to make with this. So I want to make a product that we can
I'll give you one product.
Right, well,
I'll give you one product.
What's the first product?
Can you hold it? Right now, major problem. And it can be divided. Can you have a marker?
He might have the problem.
And I have you the problem.
He does. He's solved every problem I brought to him so far.
Look, you're encoding something, right? With MPEG or any coding, right? A video of certain length, right? Takes about this amount of the length to be encoded in a new format. Well, transcoding, encoding and transcoding, both parts, right? So and then you generate the file, the output file. Okay, you can chunk this in several seconds and launch it in the cloud, right?
Now you're a mentor.
Right? And then you can encode it faster because then you merge it because every independent size is different, right? And you kind of figure out like the merging parts, right? That's just a picture, so you can even kill a frame. It's not going to be killing it, right? The problem is,
Hey Kev,
when you do a real
what are you guys
time,
building over there? What are you guys building?
that's
What are you
our
building?
problem. Because I'm if I
What do you guys
have that
build?
camera and generate this image here and make it happen, I need to have parallel computers to generate the image as fast as I can. Because what happens is otherwise I will end up with one frame and maybe some seconds of delay before I can get the formats for the iPad, for the iPhone, and Android. If you can find a way to make like for example H.264 run that in parallel, you're done. That's it. You kill Cisco. Because an encoder, you know what the price of an encoder is? You know what? $30,000. And it's not parallelized. It's a piece of hardware, and they have a little piece of like an encoder card, right? An x64 chipset, and then you send everything over there in codes in real time, and then it spits it out in a different format. But there's no way to parallelize that.
So is that a product?
$30,000. Turn it into $3,000, and you have $1 million idea right there.
Okay, so for $3,000 I can use 60 cores.
Candle 64 encode H264 real time 20 megabit high definition television. That's the question.
It's a good question. It's clearly a good question.
Video? This is going to be the thing that pays for research here for years and years.
$30,000 into $3,000.
They invented radar here.
Yeah, so that's the rumor.
That is the rumor.
It's actually over.
Over the landing strip there, yeah.
Wasn't it where Bill Gates
So,
had
you know, it's so funny, this is exactly what I'm saying in the whole video world, but you just took it to the commercial side.
Right, because Cisco has.
And it is exactly what you're saying. I mean, this is the video rendering problem.
Right.
You know, it's inherently parallelizable.
Right.
But nobody.
Lunch is ready to go. Grab food from the people.
But so when you went down there and did that thing yesterday, right? I said, oh, God, the guy's either crazy or he's got something, or he's a crazy guy with something. I know I need to get a piece of that. So it's just so. And if the latter is what you are, that's great. That you're the crazy guy with something, because I love that. I'm a little bit crazy doing some stuff. So if we
It helps in
build
this
a
business.
$30,000 solution for free, I know how to go sell the shit out of it.
Yeah.
But can we build it? What can we build to demonstrate that in the next 18 hours? You need a soldering iron? I got one in my office.
Can we just implement H264, for example, or let's say MP3 encoding, right? Which is a simple algorithm. It's open source.
Actually, there is, I believe there's MP3 samples on the STM website for this processor.
Okay.
I think it's even available for their 8-bit processor, the 35-cent processor. I don't know.
So like let's say for example we can run two samples lame, like running on a iCore 7, maybe 4 gigs of RAM, and it will take 1 minute audio. It will take like around 15 seconds to encode. That's for my brain, 15 to 20 seconds, right? And if you can do the same with 10 processors, right, simultaneously in like 1 second, you have a winner right there.
I understand that would be a winner. Now,
Because you're comparing an iCore 7 in the cloud, right? To something that is like a piece of hardware that you can
sure. Now, in order to actually test that on a physical system, I mean, I'm going to have to acquire 10 boards. I considered yesterday, should I be overnighting some more of these boards down from Amazon? You know, it's.
Well, what do you have? What do we have access to? Maybe we don't need 10 boards. How many you have?
I have one. This one here.
So you cannot run in parallel.
No, I can't run in parallel with what I have here. These are all I/O boards that I have with it. Yeah, and so you know, there's no way with what's here is now to simulate that. This is why I've been reading benchmarks and you know, what I've learned this morning by reading Drystone. I know that this has 210 Drystone MIPS. Now, where's some context for that? Well, I looked up the repository of Drystone results.
There's no boards like this anywhere in Florida. We can't get one of these.
No, they're designed out of New York. They sell through Amazon. There's a number of other.
Or we could
distributors
simulate it.
worldwide.
You can make it. There is a tool from Python. It's called Parallels. Parallels. Have you ever seen? It's a whole library for parallelization, but it's on software. The problem. This problem is not like you can solve it in software. So it's hardware just want to make it faster.
So the limit on this is the interconnect speed. It's 21 megabit interconnect.
Well, the way you have it now it is, but you know, you might have to make a derivative product where it's all these pieces don't have these wires. You need a faster bus, I think, right?
Oh yeah.
Probably not with this chip, because the bus that's being used, the SPI bus, is the fastest bus available for this chip. Now they have an Ethernet connector on there. It connects at 100 megabits, but it's not actually having a throughput of 100 megabits.
Why do we need to use that chip? Why do we need to use this board? Why can't we just use this chip?
We can just use that
Why
chip.
can't we build a parallel?
There's that chip right there. Now, and I can buy those chips in quantity for $6 a piece and lay out a board.
Wouldn't that be the smart thing to do? Just build a board with these chips on it? Why was there all these freaking wires all around?
No, I mean because for prototyping you may need to actually do wiring. But once it's built, it will.
My goal in coming at this was if I could make this only a software problem, then it's something that I know how to solve. Now, hardware, I've made hardware, I know how to make hardware. That's not, I don't claim to be expert of making hardware.
Okay.
And so to me, that's risk in a development project.
So you want to use parts that we already can get our hands on.
That's right, commercial off the shelf.
Right, but we're gonna have a hard time owning the intellectual property.
You can't own that intellectual property, that's open source hardware.
Right, so what we want to do is we want to take the hardware, this piece, and build that kind of a rack.
No, but the issue there is that, for example, let me give you one simple example, right? Let's say that we have a movie here, right?
But wait, before you get there, if we can't own this, why would we build it?
Oh, because this is where you own a lot of intellectual. Let me explain to you the problem, right? This section will take me coding 1 second, but this section will take me coding 3 seconds because there was a car chase. And here it's like a little bit flying around, right? If I run this in parallel, I need to find intellectual property so I can divide this in 3 sections, so it can be 1 second each.
Okay.
So because when I merge everything, if one thing is 3 seconds and the other one is 1 second, I have to wait 2 seconds before I get the 3 second piece, right?
Right.
But if I can parallel, you see, that's the IP there. How to find, in a whole video, how to segment it correctly so it maps the parallel array that you have. That's the intellectual property.
Now, that is
That's the IP.
That is valued protectable IP. Now, the
Because
way
it's
I'm
very difficult to
approaching,
do.
the way I'm approaching this is you're an application developer for this platform. That until I build this platform, you can't do that. You can't buy anything. You can develop it on a parallel computer.
No, I mean, you guys can simulate it with parallels, for example, in multiple cloud. The issue is that I have multiple computers simultaneously to work. When I can have this processor dedicated for that purpose, and I don't have to do memory, I don't have to do anything. I just compute this.
Right, but what you have to do is, I mean, the way you use a parallel supercomputer, there's different programming techniques. You don't just write plain old C and expect it to work.
Right.
On a closely coupled microprocessor.
Feel free to grab lunch whenever you guys want, all right?
Yeah, you compile it using things like loop unrolling and run inner loops on different CPUs, that kind of stuff. That doesn't apply here. You're many layers above that in the functionality that you're asking. So you could develop your concept. You could, but in order to actually test it and verify it, you're going to have to go use hardware. Today you can't buy on the scale that I'm saying that this can be done. You'd have to go out and get a small university supercomputer or something.
You know what else you could do? Actually, maybe you spoke about virtual machines, right? This is what you worked on before, right?
Yeah.
I worked on the Java virtual machine a month ago. I was on the Java virtual machine, JVM. I went to all the conference, all those things, right? So I was there, right? And then I
Do you
worked
know
on.
Bob Van
No.
Son, yeah.
I don't know, it's like a bunch of guys over there. Anyhow, so the issue with that you may face, that I can have a value thing, is how a way to have a virtual system that for me and for everybody is the same programming methodology as a regular computer, right? And then you build a virtual machine that will parallelize everything behind the scenes, so it will match any array in any format. In other words, what you're building is like a virtual, like a SAN or VMware or parallelization for your hardware.
What I know about parallelizing today, based on the concept you're saying, what I said before about compilers doing loop unrolling. Now, the compiler requires intimate knowledge of the hardware in order to be able to do that, and on distributed parallel processing, you can't do that. You have to have closely coupled shared memory.
Right, but that's my point. That makes it so difficult. So make it faster, to make it easier, you need to put a layer. So for me as a developer, I still write for loop. I don't care. I compile it. The compiler compiles it. But the VMware is so smart. So look, this guy wrote this for 1 CPU or 2 CPUs or 4 CPUs or 10 CPUs, and he goes on and parallelizes everything, and I don't have to deal with that as a developer. That's the value there.
The state of the art today, as I understand it, people use thread libraries to do this, and once they've directed it, this piece goes in this thread, that piece goes in that thread, then you can absolutely do what you're saying. Because the compiler, the system, the operating system understands threads and say this thread to this core, this thread to that core.
Right.
Okay, that's just inherent in how threads work. But to just take a non-thread aware, non-multi-processing algorithm and just kind of by inspection say, oh, I see, we could make this into, this runs